Okay, let's unpack this. Remember those math classes? Calculus, maybe?
Oh, yeah. Slopes,
Yeah.
areas under curves, stuff like that.
Exactly. And you probably wondered, like, when am I ever going to use this?
Huh. Yeah, a common thought.
Well, get ready, because today we're diving deep into how that math connects to something, well, maybe surprising,
Which is,
your food.
okay. Intriguing. So calculus in the kitchen.
Pretty much. Our source material today looks specifically at differentiation and integration, core calculus concepts and how they actually show up in food science and even food security.
So not just abstract numbers, real-world impact.
That's the idea. Our mission really is to explore those connections, how the math relates to, say, the quality of your food, how it's packaged.
Okay. The source mentions integration first, right?
Yeah.
For packaging.
Yeah, that's kind of the more straightforward one, I guess.
It makes sense. Integration is about summing things up, finding totals, like volume.
Exactly. So food scientists or engineers can use it to figure out precisely how much cereal fits in a box.
Or liquid in a bottle, yeah. Calculating the volume of these often complex shapes.
It's the perfect tool for measuring that total accumulated space,
Definitely a practical application.
Yeah.
Summing up all those tiny little bits of space to get the total.
Right. But the source really emphasizes differentiation, and this is where it gets maybe less obvious.
Okay. Differentiation.
Mm.
That's about rates of change, how fast things are happening.
Yes. And the source links this directly to food security through, get this, modeling sugar crystallization rates.
Sugar crystallization. Like when honey gets hard or candy gets grainy.
Exactly that. It feels like a bit of a leap, doesn't it? Calculus and sugar crystals.
It does seem like a jump. So how does understanding the rate of crystallization connect to food security? Isn't that just about, texture?
Well, that's what I thought at first, too, but it's more than just annoying grainy bits in your jam.
Okay.
Think about shelf life. Stability. If sugar crystallizes too fast or unpredictably.
The product quality goes down. It might spoil faster.
Precisely. And that leads to food waste. Differentiation lets scientists model how quickly those crystals form.
Under different conditions, I assume, like temperature changes during shipping.
Exactly. Temperature, humidity, even ingredients. How fast does it happen? That's a rate. That's differentiation.
And knowing that rate helps predict shelf life.
Yes, and formulate products that are more stable. Choose the right packaging. Set realistic expiration dates.
I see. So it's about consistency and predictability.
Which is vital for large-scale food distribution, right? Getting food reliably to people, especially over long distances or in challenging environments.
Right, where spoilage is a huge issue.
Mm-hmm.
Reducing waste is definitely part of food security.
So it's not just about a slightly less pleasant texture. It impacts whether food is actually available and usable when it reaches someone.
Yeah, okay. So differentiation provides the mathematical language to describe that dynamic process.
Yeah, to analyze how quickly things change over time.
Yeah.
How sensitive is this jam recipe to temperature fluctuations? Differentiation helps answer that.
It allows for prediction and ultimately building more resilience into the food supply chain.
Makes sense when you put it like that. So what's the big takeaway here?
I think it's that math, even stuff that feels abstract like differentiation, it's actually a practical tool. It's used to model these dynamic processes in food, like sugar crystallization.
Which impacts quality, shelf life.
And ultimately contributes to food security by cutting down on waste and making sure food is reliable.
And integration plays its part, too, in the more physical design side, like packaging volume.
Right. Both concepts have tangible roles.
It really highlights how math isn't just stuck in textbooks. It's embedded in, well, everything. Critical systems.
Absolutely. It's often working silently in the background.
So maybe a final thought for you listening. Next time you're, I don't know, looking at a jar of honey or even just thinking about supply chains, consider where else the mathematics of change differentiation or accumulation integration might be at play.
Silently shaping your world in ways you haven't even considered.
Yeah. Something to chew on.